On graphing transformations, we're going to graph the parent function, identify transformations that exist. We'll graph the parent function and the new function on the same coordinate plane. So here's our first example. We have the equation y equals x minus 3 all squared plus 4. So we want to identify who our parent is. Notice that this is a squared term, so our parent is a quadratic function y equals x squared. So let's go out and find the ordered pairs for our parent function. So we say x, and then we're going to evaluate at y equals x squared. So we'll start with 0. When we substitute 0 in, 0 times 0 is 0. Substitute 1 in, 1 times 1 is 1. Substitute 2 in, 2 times 2 is 4. Now let's go with negative 1 and negative 2. Negative 1 times negative 1 is 1. Negative 2 times negative 2 is 4. So now let's go ahead and graph it. I'll graph it in blue. 0, 0. Right 1, up 1. Right 2, up 4. Left 1, up 4. Left 2, up 4. So there is our parent function of our quadratic function. So I'm going to go ahead and name it for us. Right down here. All right. Now I'm going to go ahead and identify who our transformations are. So let's first talk about this plus 4. This plus 4 is outside the function. It affects the y-axis. So since it's a plus 4, we're going to push all of our y values on our y-axis up 4 units. The other transformation that exists is a minus 3. It's inside the squared, the x squared term. So I always tell my students, think opposite. So when we go on the horizontal axis, the x-axis, you'd think you'd want to go left 3. We're actually going to go on the x-axis right 3. So in order for this to happen, we're going to have to add 3 to all of our x values. All right, so when we're done with our red and green values, we'll have our new function. So let's start with our first column. We're going to add 3 to all of these y values. So 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Negative 1 plus 3 is 2. Negative 2 plus 3 is 1. All right, now we're going to go ahead and add 4 to all of our y values. So this column here. So 0 plus 4 is 4. 1 plus 4 is 5. 4 plus 4 is 8. 1 plus 4 is 5. 4 plus 4 is 8. Now we should go ahead and see our new function when we graph these ordered pairs with the transformation of right 4 and up, or right 3 and up 4. So that 3, 4 is our first point. So we're going to go right 3 and up 4. This is what we call our critical point, or our vertex. Then we'll graph 4, 5. So go over 4 and up 5. Then we'll graph 5, 8. So over 5, up 8. Then over 2, up 5. And then over 1, up 8. There is our new function in the purple that is translated horizontally right 3 and up 4. All right, so I do want you to identify your transformations. So in short, you're going right 4, so the horizontal translation. Actually, that was right 3, wasn't it? Sorry, right 3. And then the other one is up 4, so that's a vertical translation. right, let's do another one. Now we're giving you h of x equals the square root of x plus 3 minus 2. So let's identify our parent first. Notice we have a radical. So our parent is y equals the square root of x. So our parent is the square root function. So we're going to plug some numbers in for x to get our y values out. So let's start with 0. The square root of 0 is 0. Then we'll do 1. The square root of 1 is 1. When I plug in 2 and 3, I don't get a nice, pretty number out. I don't get an integer. So I'm going to go and jump up to 4. Because 4 is a perfect square with 2. 2 times 2 is 4. So the square root of 4 is 2. Now if I choose 5, 6, 7, or 8, they're not nice. I'm going to jump ahead to 9. The square root of 9 is 3. I'm going to stop there on the positive side. Now if I plug in negative 1 or negative 2. If you remember, a negative 1, a negative 2 do not exist. You can't have a negative square root. So let's go ahead and graph this parent function. So we have 0, 0, our origin, over 1, up 1, over 4, up 2, over 9, up 3. So here is our parent function in the blue. Now let's go ahead and identify our transformations. The first one is outside the radical. Remember, when it's outside, it affects the y-axis. It's a minus 2. So we're going to go y minus 2. We're going to go down 2 units. So we're going to take this in blue function and move it down 2 units. So it'll look like that. All right, let me erase that because that's not our final answer. Then we have a plus 3. The plus 3 is underneath the radical. So that affects the horizontal axes. So I always tell my students, think opposite. So it's going to actually move it to the left 3 units. So in order for us to move it left 3 units, like this, we need to subtract 3 from all the x values, so x minus 3. All right, so let me erase that to come up with our final answer. All right, so let's start with the first column. We're going to subtract 3 from all of our x's. So 0 minus 3 is negative 3. 1 minus 3 is negative 2. 4 minus 3 is 1. 9 minus 3 is 6. We can stop there. Because remember, these two, we don't have to worry about. All right. Now let's go to the second column, the y's. And we're going to subtract 2 from all of them. So 0 minus 2 is negative 2. 1 minus 2 is negative 1. 2 minus 2 is 0. 3 minus 2 is 1. All right, now let's go ahead and graph them. So here is our new critical point. Our critical point for our parent is at 0, 0, the origin. Now we're shifting that critical point left 3 and down 2. Now we'll graph the rest of the points. Left 2 and down 1. Right 1, up 0. And then right 6, up 1. We have not changed the shape of this graph. We have just moved the graph 3 units to the left and then down 2. So as our transformations, our left 3 on the horizontal axis, so horizontal translation. And then down 2, which is a vertical translation.